Hi, my name is Junda Huang. I'm a bioinformatician working in the Radboud UMC as part of the Netherlands X-omics initiative and the Trusted World of Corona project. So today I'm going to talk about our demonstrator that's analyzing the multi-omics data through the fair data points. And mainly I will focus on the verification part of this analysis process. So first of all, about the TWOC, the Trusted World of Corona project. It was set up during the pandemic, and since a large influxes of uncontrolled information was popped up and causing the issue of the potential danger and the trustworthy and the privacy issue of the information. So in this project, we aim to build a platform that can harmonize data and be securely shared and connected and queried and being used. Some background about the data set that we're using. It's from this article, published article from 2020. It's a large data set of more than 200 patients and controls, and consists of multi-omics data in different levels and with different measurements and very complex data. And the goal of this platform, of this demonstrator, we're trying to show that trying to recreate the result from this paper that established the link between this, the COVID severity and the potential use of the drug tocilizumab. And this analysis in our demonstrator is mostly using our fair data cube infrastructure that my colleague just explained early on. So I will not go into in detail. But the verification process that I'm explaining right now will mainly use the metadata registry, which is the fair data point. So basically, before the federated analysis in the fair data cube can be deployed, the verification process needs to be done. We need to get the verified data and metadata into the registry. The verification processes are mainly based on the investigation study assay framework, the ISA framework. For the study design, the different omics experimental data. Plus, we also see a lack of experimental feature metadata that feature metadata coverage within the ISA. We made additional effort to incorporate that as well. I'll come back to that. And also for better interpreting the biological context of the omics data sets, we also need to verify the phenotypic information, which we use the phenopackets framework. So first of all, the overview of the assay framework, the data model, which are showing here, where the investigation mainly covered the project context, and the study will focus on the specific study design and or like a specific experiments. And in our case, the assay part will cover mainly the analytical processes and at different omics level. So in this example, we show that the omics feature, which lack of a unique ID, we incorporate the tool BridgeDB to find their unique ID. In this case, the KB database. And as I mentioned earlier, we capture the phenotypic information through the phenopackets framework because of its extensive coverage of clinical features. And so after the verification of the data, we analyze through the Sparkle query through basically any Sparkle endpoints. In this case, we choose the TNO Diamond dashboard, which in this platform, we can run Sparkle query on different metadata registries and perform simple analysis and visualization, which also enables the federated analysis later. Thank you very much.